I have two sequences. Are they converge or diverge? To find out, I will try n equals to 1, 2, 3, 4, 5 for both sequence. Okay, starting from the pink. So if I have a1 that is equals to sine, and then that will be 1 pi over 2. Sine of pi over 2 is equals to 1. And then a2, I have sine of 2 pi over 2 that is equals to pi. Sine of pi is equals to 0. So this one, if you don't remember this one is based on the unit circle. And then a3, I have a sine 3 pi over 2. Sine 3 pi over 2 is a unit circle on the y-axis that is between quadrant 3 and quadrant 4. So y is equals to -1. And then a4, that is a sine 4 over 2 is 2 pi. Sine of 2 pi is equals to 0. And then a5, that is a sine of 5 pi over 2. 5 pi over 2, that is equals to 1. And then a6, you can just keep on trying. And then sine 6 pi over 2 is a 3 pi. That is back to 0. So this one, you can see that right here. We can see that 1 and then to 0, and then we will do, and then we will start from 1 again. So this is a pi over 2, pi, 3 pi over 2, and then 2 pi, and then back to 5 pi over 2. So this is from a pi over 2 to a 5 pi over 2. So in the unit circle, we just walk a full circle. And then starting at this point, we will walk for another full circle again. Okay, that means the y value is going to be bouncing between these values. So what I am going to say is, I will just go ahead and then write a limit. When n approaches to infinity, I have sine of n pi over 2 that is equals to sine of infinity. Sine of infinity. This one we cannot determine. So this one we have to say the limit does not exist. So does not exist. And then the sequence diverges. All right, the green problem is done. So let's move on to the pink problem is done. Let's move on to the green problem. Testing n equals to 1 to 5. So when n is equals to 1, a1, that is a -1 to the first power, and then 2 divided by 1, that is a -2. And then a2, -1 square, and then 2 divided by 2, that is equals to 1. So we can see that the -1 to the n power, that makes the negative sign alternates. When n is even, -1 to the even, you get a positive. When n is odd, you have -1 to the third, and then 2 over 3. This one gives you a negative. And then a4, -1 to an even power again, 2 over 4, that is equals to 1/2. And then a5, that is -1 to the fifth, 2 divided by 5, that is -2 over 5. And then, okay, let's try something big. So let's try 800. 800. Okay, my palm keep tapping on that to change the color. -1 raised to 100th power, 2 divided by 100. So that is, I can say, you can leave that as 2 divided by 100. So what happened when n becomes very large? When n becomes very large, so I can do limit as n approaches to infinity. This one, I have -1 to the nth power. And then what matters the most is 2 divided by n. Because the negative sign doesn't really change anything, so you will have -1 raised to the infinity. I don't care about this. I care more about the 2 divided by infinity. You have 2, you divide that into infinitely many pieces. Each piece is nearly 0. Is nearly 0. So this one, when n equals to a value, you start at 2 and then you move on, right? And then you can see when n becomes really large, that gives you a large denominator. 2 divided by a large denominator, regardless positive or negative, that quantity is very close to 0. So this one, as you can see, we write a sequence, right? So in the previous video, I write a sequence, the numbers from left to right. So as you look all the way to the right, so this one, we put this in one row. In one row, 1 0 negative 1 0 1 0. You write from left to right. As you look all the way to the right, those quantities are so small, near 0, and then we can say the sequence converges. So sequence converges. Alright, so that is the end of this video. If you like the way I explain the sequence, the convergence or diverge, give this video a like, subscribe to my channel for more contents like that, and I will meet you all in the next video for more similar lessons. See you there.